you started by going ahead and solving each of these. Now, in order to solve these, of course, it's all about factoring first as much as is completely possible. So in number 1, it's already partly factored, but it can also factor even more. That first parentheses can turn into x minus 2x plus 2. The second parentheses, minus 12 and plus 12. Now that we've gotten to that point, that is now completely factored. And now that it's completely factored, we can go ahead and put in what our answers are. Which, actually there's an error in the way that's written. That should be x equals 2, negative 2, 12, and negative 12. Those are the values that make it equal 0. All right, and then taking a look at number 2. Again, we have to start by trying to factor it. In this case, it's a little bit harder to do that initial factorization because we're adding to negative 109 and adding to 900. But as it turns out, the first thing that I think of when I look at 900 is 9 times 100. And that turns out to be the one that's going to work for us here. So I got x squared minus 100 and x squared minus 9. Since both are x squared minus a perfect square, we can factor those even further. Now that we've factored those as far down as they go, then we have what x equals. And so there x equals 10, negative 10, 3, and negative 3. That should be your final answer. And what you will be getting for both of those. Today we're going to be throwing in a little bit of kind of tossed in practice here on exponent rules. Because it's been a while since you probably looked at specifically thinking about these exponent rules, and they're starting to come up more and more. And so we want to take a moment and actually think about what those rules are and how we use them. It's going to be especially useful in the direction that we're actually heading with our work that we've been doing recently. So it's a good timely reminder, I hope. So you write down number 1. And I'm multiplying the x's. We've actually been multiplying x's with exponents here quite a bit recently. When I multiply the x's, what do I do with the exponents? We add them, absolutely. So in the case of number 1, that's going to give me x to the power of what? This is where it's kind of tricky. It's actually x to the 11th.
Add it up. It's 11, not 10.
And this is the problem that a lot of people run into, is a lot of people initially say 10 because we say, oh, okay, I need to add the exponents. And then our eye naturally gets drawn to just look across that line and just start adding things. And so we do 6 plus 4 there. But remember that we cannot just look straight across there. We actually have to think about what's going on with each of the x's, because this x here actually has that invisible 1 written on it as an exponent, so it's actually 6 plus 4 plus 1 there. All right, now on to number 2. In number 2, you'll notice the difference between 1 and 2 is that 2 includes both a's and b's. We have to treat each separately. So you're going to take all the a's together, and then you're going to take all the b's together. And so in order to do that, the very first thing I do is I look at all my a's. And it starts with an a, b to the 7th. That is not a and b to the 7th. That is a to the 1 times b to the 7th. So that's just a to the 1 there. So I have a to the 1, a to the 5th, and I have a squared. So that's 1 plus 5 plus 2. So that's going to give me a to the power of 8. Then we repeat the same process. For the b's, I got b to the 7th, b to the 3rd. So that ends up giving me b to the 10th. And there's your answer. A to the 8th, b to the 10th. The most common mistake I see when people do that one is dealing with this a right here. A lot of people will look at that as like it is, as if it is ab to the 7th in parentheses. But that's only true if those parentheses are present. Without those parentheses, it really is a to the 1st times b to the 7th. All right, now on to number 3. When doing number 3, there's actually a couple different things we're going to be doing. The first thing that I would suggest you do, simplify the top and simplify the bottom separately. All right, so now when we do that simplification on the top, I have m squared and m to the 8th, so that ends up giving me an m to the 10th on the bottom, or on the top. Then I do n to the 6th and n cubed, so that gives me n to the 9th. do the same kind of thing on the bottom. We got m to the 12th, n to the 10th on the bottom. Now once we have that, now it's a matter of, okay, what do I do from here? Right? Well, if multiplying means I add the exponents, what does division mean?
Subtract.
Subtract them, yes. We're going to subtract the exponents. But if I look and do it that way, then that ends up being m to the 10 minus 12, which is m to the negative 2. When we get a negative 2 in our exponent, or any negative in our exponent, do you remember what that means? It means that m is actually in the bottom of the fraction. So it actually means that in our answer we're going to have an m squared in the bottom. Let me show you why. Because you can memorize the rule, but if you don't understand why, it's not as helpful. So we have m to the 10th on top. That means, remember, the 10th power means that we are multiplying m times itself 10 times. Why did I make it 10 times? That's a lot of m's to write. I think that's 10. Yep, that's 10. So that represents m to the 10th. That's actually what we mean when we write m to the 10th. Thank goodness we can write it as m to the 10th and not have to write all that stuff. Then on the bottom, we have m to the 12th. Okay, there's 12 m's on the bottom, or at least scribbles that I'm meaning to look like m's. So if I'm going to reduce this fraction, writing it all out the long way, really what I'm doing is I'm canceling out pairs of m's. Anytime I see an m on the top and an m on the bottom, I can cancel those. Notice what that leaves me with. This shows why we subtract, because I'm trying to figure out what the difference is between them. So like after I cancel out all the shared ones, what's left? But notice that what's left is 2 m's on the bottom. So the negative means that there were actually more on the bottom. Wherever there was more at the start means that's where there will be that variable in your answer. So let's use that here with the n. With the n, we have n to the 9th and n to the 10th. Where do you have more n's, in the top or the bottom? The bottom. That means that my answer is going to have the n in the bottom. And what is the exponent on that n? 1. Because 9 minus 10 is a negative 1. So it means it would be n to the 1, which I don't actually have to write the 1, right? N to the 1 is just n. Now, if I did all that, I now have some weird-looking fraction with nothing over m squared n. We do have to have something on the top. What is always on the top? 1. And so then that's what we're looking at for our final answer.